Okay, so without much ado, I want to invite Alex to start off our training for us. So Alex, over to you.
All right, PK. Good morning, everyone, once again. Um, Today or this morning, we are going to do a walkthrough about Docker as a way of deploying our application in the various environments. So we are going to actually uh, do a brief description about the Docker itself, how to use it, and why it's there. Then, if still have sufficient time, we look at how to work with some Docker files and publish images and run a Docker image as well. So let's start. All right. So I believe most of us are conversant with Docker because I think last year we had the same session. So I believe most of us actually is actually using Docker in their various development environment. But I think some of us too, we are now adjusting to the Docker environment. So Docker is just a runtime system that actually it allows you to containerize your environment, your development environment into one single environment without interfering with your host machine or your host service. Okay. So what it simply means is that when you are working with an application or you want to deploy an application, you need to actually install some utilities, some packages, some other stuff, some files, environmental variables, some changing stuff. So for you to be sure of whatever you're doing without conflicting with the host machine's file system, Docker make that provision for us to containerize or package the entire application in a single process or single environment. Okay. In so doing, it makes your application in isolation with other application running on the server or on your local machine. So let's look at the key features about this. All right. So as an engineer, what you'll be doing is to build and run an image as a container. Now, you see, in Docker, we have some few terms you need to familiar yourself with. The first one is it's a Docker image, a Docker container, okay, the volumes, the networks and stuff, okay. Now, when you say a Docker image, okay, it's a blueprint that represents your entire system or your entire operating system or any possible related packages or utilities needed to build your application. You get it? So mostly when you go to the public registry or the repos for Docker images, they have certified and approved images that represent a particular environment. It could be Ubuntu, it could be Windows, it could be Python running on Ubuntu or running on Debian or on Windows. So everything that you need to build Python application is being packaged in that particular image. Okay. So your job is to pull the image, then make an instance of it. So the moment you make an instance of it, we call it a container. Okay. So a running image is called container. You get it? Yeah. So apart from that, you can also create your own images. Okay. So what happens is that you can leverage on what others have done, then build upon it. Okay. So we also work through that, how to do that as well by using the Docker file. Okay. So like I said, the Docker image allow you to create an instance of the image called a container. Now, when you create these images, okay, there's a provision for you to store your images. Normally, we call it a registry. So on the Docker level, you can create a local registry, which is actually private to you yourself or to your company, or you can create a public registry. So one typical example, one typical public registry we have is a Docker Hub. The Docker Hub you can create a repo over there and put your image over there and make it public or private. You know, so the number of package that you can have depends on the package that you're using. If you want to use it for free, there's a limitation on that. Okay, but if you want to make it public, that one there, okay, you can publish as many as you want to get it. But I want to make it private. Private is mean private. No one can have access to you except you or the person who have access to that particular repo on Git Docker Hub. Okay. All right. So, like I said, we publish our images on Docker Hub. That is public registry. But you can also do the same on what? Private registry. You can do that configuration at your server level. Then you push all your containers, all your images in there. So anytime the operation team want to deploy, they go and pull the images from the registry and run it. Okay, that's why I said this particular training, we need both the entire team of the operation as well as the development. Most of us don't actually use Docker, but for the operations, I think very soon you end up deploying Docker containers and stuff. So it's good that all of you are here. All right. So what about if you want to deploy multiple containers or multiple images? It's possible. Docker has something called Docker Compose that you can use to do that. So we also, I think this one, the Docker Compose scenario, we'll tackle it when we start deploying it, probably tomorrow. Yeah. So that's it about Docker. Let's move down. Like I said, once you instantiate an image, we have what? A container, you get it. So all these are explanations. I'll share the slides when I'm done so that those of you who want to go through. It's portable. What it means is that once you have a Docker runtime, you can run it anywhere, irrespective. On your typical server, on your virtual server, you can run a Docker inside a Docker. You understand my point? So it's possible everywhere. Okay. So you can have an instance of a Docker image running with another instance of another image, run another inside that particular image as well. So everything is possible over here. You get it? That's why you say it's portable. Portable means you can run everywhere, irrespective. You just have to package your application in the image, then you ship it to the other side, then they will deploy, then we are good to go. Anytime there's a change, there's a way of doing it. We'll get there. Okay. So I don't think the one important thing is that okay, it provides custom file system, like I said already, dependencies. So all this kind of stuff is when you are building an application, you need all this stuff to get your application running, right? So Docker is able to isolate all this kind of stuff, file system, dependencies, configurations, scripts, binaries, environment variables, default commands, and other metadata. Okay, so other related data that is actually unique to that particular application. Because just imagine, let's say your local machine or your server, and you're having about 6 or 5 applications without Docker. It's a struggle, okay? Because you need to learn how to manage or control this kind of environment, this kind of changes. You get it with the dependencies, with the environmental variables and stuff. Okay, it's a hell, but Docker has come to save us. All right, let's go down. So we are going to create a Docker file, small demo, then we are going to build and run. Then afterwards, we'll try and publish to the Docker Hub. Then that will be end of today's presentation. All right. All right. So nothing much, but before that, let's see if you have any question. Then I think it'll be good to go for the practical aspect. All right. Yes. Any question so far? Whilst I switch to the development side.
Hi, Alex.
Yeah. Okay.
Okay, so I want you to call anyone to give us a brief summary of what you just said. I want to be sure everybody's following. So you can choose anybody at random to just give us what they just learned from what you've presented.
Okay.
Anyway, I feel it's so brief, and that people, of course, it's actually some people's first time of actually getting the introducing the Docker. So I don't think they might. Some people might even get it for the first time.
Yeah, that's why we expect them to ask questions. So if nobody's asking a question, then it means they understood everything. Because it's time you are using. So if you will be here and then you don't understand it clearly, unless it's giving you the opportunity to ask questions. So if you don't ask, it means you either understood everything well or you already know it.
Yeah, I think so. I'm expecting question though, but okay. So I think what bigger question people normally ask is about the difference between Docker and the typical virtual machines. You see, they are in the same design, but the only difference is that Docker is a lightweight and cost effective. If you store Docker on a server, okay, the amount of memory and the processing time that is going to take as compared to VMware's, okay, is huge. So people prefer the lightweight instead of that huge VMware or virtual machines that is going to be stored on your servers. You get it. That with VMware or with the virtual machines, you can also install Docker inside. Mostly most of us are having servers in the cloud. So you can install the Docker inside, then within your magic on there, you get it without any problem. Okay. Yeah. It's good that you've understood. So I think we are good to go. All right. So Docker has a small application on GitHub that we're going to use for this demo. So the most important part is for you to understand the demo that we're going to do, because it's the fundamentals. Once you get the fundamentals right, everything will be fine. Once you don't get the fundamentals, you will still struggle. But I don't think it's something difficult. It's easy to understand. So let's roll. All right. So like I said,
Alex,
yeah. Okay.
yes. So maybe we'll do the questions after the demo.
Yeah. Yeah. Sure.
Those who are still sinking in the information.
Okay. So we are
Okay.
going to pull that particular application. Is a Node.js. All of us know something about JavaScript. That's why I'm going to start with JavaScript. I believe once you go through computer science, technology, computer engineering, whatever, IT-related course, IT-related programs in university, you should be able to do JavaScript stuff. So this one, it cut across. All of us know something about JavaScript. So that's why I'm going to start with this so that we'll all be on the same page. Tomorrow, God willing, we'll be looking into what typical Django or Python application deployments. So, all right. So let's do JavaScript today. So let me pull. So as usual, if you want to pull a repo, you use the git clone. Most of us is aware of this. Then you specify the location. So github.com docker getting started. That's the name of the application. Getting started up. Let's see. Okay, we got it. So this repo is what Docker community has
food source for soldiers
provide for the developers that are actually new to Docker to start building application using Docker. Okay, so we have it here. Yeah, see, here we go. So let me check into the repo, then take it from there. So let's watch the inside. Yeah, you can see it's a typical Node.js application, right? So in Docker, if you want to build your own image, there are images on the Docker Hub that you can pull. But if you want to build your own image, we start with a file called Docker file. The name remains the same. It's like this. So let me create a file. Okay. Docker. If you make a mistake, it won't work. In regards to the name, so Docker file like this. Okay, no extension like this. We are good to go. Okay, then let's go into our VS Code to get our directives into the file so that we can actually create an instance for this particular image. We build, then run. Okay. Okay, so let's see. Okay. Docker demo. All right, so we have it here, as you can see. So you see, Docker, I already have the Docker extension being installed in my VS Code. So you can see that it has detected that it's what a Docker file. You see the Docker image is there. Now, if you want to create an image, because you cannot do everything yourself, and it's always good that you leverage on what others have done, or you rest on the shoulders of what other engineers. So what do? We pull an image from the registry or the public registry, then we add our own to it. So normally we are going to add layers to this particular image that will come from the public registry, which is the Docker Hub. Okay, so we need a node. So we are saying from, okay, so from an image called node, but we need in the version to be what 18, which is an Alpine version like that. You get it. So the Alpine version typically has the Linux version, to the best of my knowledge, right? So what this particular directive is saying is that get an image from the Docker Hub called node, okay, with a version 18, okay, with a special tag. Okay, after the node, the rest is what the version, what the tag, okay. So when you get that, what happens? We are going to work in a directory, or we are going to work with a directory called app. So inside the container, we are telling the Docker daemon or the Docker runtime to create a directory called what app. Okay, so that's what it means. So as the name implies, work directory. Then what happened? We copy everything in our current directory. So you can see that this is our current directory. This is our current scope. Okay, the spec, the source, the Docker file, the package.json, the README. This is our current scope. You get it? So copy everything from there to the containers directory, which we have defined as what? As app. It could be anything. It could be anything. It could be anything. I can just use it to, let's say, my app. It could be anything. It's conventional, right? But I think app is straightforward. You get it? All right. Then what do you do next? We install the packages. Let's see what is here. Is it a number of packages over here, right? So we need to install them. After we remove the file. So this is just like what we do normally in our normal app development. See, this one, the from, gives you an operating system as well as what related packages that you need to run what node. You get it? So you have node running on operating system. You get it? Then you define a directory. You move your app. You move your app to that particular directory. Okay. Then you installed the packages, right? You install the packages. So you see, we are not using what do you call it, npm. We're using what? The yarn. You know, Node.js developers will tell you that there are two notable packages, package management in the Node fraternity, the yarn and what? the npm. Correct me if I'm wrong. Okay. So we are saying that we are telling Jan to what? After we've copied the current scope or the current directory to the what? To our Docker container directory, which is the app. You should what? You should install a production grid what? Version of the dependency. So production. Are we okay? Then afterwards, what next? You need to start the, what do you call it? We need to start the index file. So with that command, we use the cmd. See? So it's node. This is very, very common to our Node.js or JavaScript developers, the front-end guys. Okay. So let's go and look for the index file. So here it is, right? So we specify the what? The parameter, which is src, the source. You get it? Then index.js. You see? Now let me go over this once again. You see, this is the, normally in a typical local environment, you do a node, then you specify the word the file, then the application will start, right? And let's see what happens here. We are telling, when you step into the container, okay, the container has a directory called app, which has all of this. So when I say that, when you get inside the container called app, right, with a folder called app, then go to the source file, the source folder, with a file called what? Index.js. Okay, so we are telling Node to start a particular file so that we'll have application running. Then what next? For us to access the application, we need to have a port. You know, we already know that in software development, ports are channels of accessing a running application. So I think from 0 to 2023, sorry, 2023, they are all reserved. They are built in what port. You can't use them in your development or in your application deployment. No. Okay, they are things that is being built into the system. Okay, something like port 22, port 21, port 53, port 44, 443, port 80, and that kind of stuff. Okay, they are being reserved, so we can't use them like this. Okay, so we are saying that we want a port called this port 3000. Okay, I think from 1024 to 49,000 plus, we can use them. We can use those ports to do your magic, right? Now, when we get here, I think we are done. So we just have to build this particular image. You get it. Then we'll have an application running. Let me go to the terminal. All right, let me step in. You cannot run it at this place because we don't have the Docker file here. You can see you have to check into the word getting. Yeah. Then let's see what we have here. We have a Docker file here, right? So how do you do that? It's very simple. So we have to build the image first. Then you can run the instance of the image. Like we said already, the instance of a running image is a container. And that is the application that you can access. Okay. So let's do it. So Docker build. We have to give it a name. So let's give a tag. So let's say Docker demo. All right. Now, if you want to specify the location of the Docker file, because in the same directory, you can just do this. That represents what? The dot represents the current directory. So let's run. See what, yeah. So you can see that it's pulling the node first, then it will build the rest upon it. You see? So every line has its own checksum hash. So when I make a change right now, it's going to rebuild again. But let's see what happens next. So it's fetching the dependencies and stuff. You see that? It's done. It's done. So if I run it again, because it has been cached, it will not run it again. You just read from the cache that tell me that you've not made any change to your Docker file. Okay. So let's see. Let's do it again. You see how quickly it's finished building, because we already run. So it reads from what? From the cache. But if I make a change right now, it will be a different story. I'm going to run it again. So that's the sense of the cache. Okay. Mostly, if you don't want to, you just have to pass the no cache param, then it will run it again for you. But this time around, we have it running. So let's see. Now we have an image. Let's create an instance of this image. Okay. So how do we get our images? So Docker PS or okay, let me do this. Docker images. Okay, so let me use the PS. So I'll get the running and the not running ones. Let's see. Let me grip. Okay, let's see. Okay, let's see. There we go. Okay, so I think let's run the instance, a Docker run. Okay, so let's move on. So now we know we have an image in the system. Let's run it. So Docker run. So the D means that we want to run the image in a detached mode. Detached means that we are going to decouple the running process from the current process. You get it? For it to be in a what? In isolation. So detached. Then the P is for the port, or from the publish what port. Where do you want to run the application? Which port do you want to specify? We already have what? 300. So we can also do that. Then you specify 3000, sorry, not 300. Then, so the first before the colon representing the port on the local machine. The second one representing the port on inside the what? The container, all right? Then you specify the image name. So nalo Docker demo. All right, let's see how it goes. I think we have it running. It's running on port 300. So let's see. Yeah, there we go. So we have this one running. So you can see that it's running on this port, right? If you want to access, it's very simple. You copy, go to your browser. Here we go. We have an application running, right? So we can add some few things. Now, demo. Now, Docker. So I think you get the idea. So we have an app running right now, okay? So we're running on port what? 300. So if you have to change the port, you know, it's not going to work. You understand my point? Let's say 2000. There's no application running on that particular port, okay? Now let's see what you can do with this in terms of what? Scalability. Let's say Then we're having too much traffic. You have so much traffic coming to your end. So how do you do that? You get multiple instances of this, right? You see this one's running. But let's see what happens if you're trying to create another instance of this particular image with the same port. Get error. Okay. So it's telling that the port is already used. What about if you change the port to 3001? We have it running. This is the hash. You change the port to 3002. You get the idea, right? So right now, we have 3 instances running, right? So if I go to the browser, okay, let me go to here. Yeah. Oh, this one will be. I'll go to the browser and specify 3000. I should have access to the first app, the first instance. If I specify, if I specify 3001, I should have access to the second app. They're all running. So if you have a huge traffic coming to your end, we create multiple of this to scale your system. They're all running. So we have 3 apps running right now. So this is a 3001, right? This is another one. So let me see. I am 3001. You see, there's no interference. So I am 3002. So when you go, you can see that each of them is in isolation. The container allows you to isolate the environment of each app. See, this is 3001, 3002. This is the first one we created, 3000. You get it? And the beauty is that you can connect each of these to the same database. If you want to go extra mile, if you want to make things more scaled or more scalable, you can connect this one to different database. You can do this one to different database. So this one could be database to only users. This one could be database to only payment. This one could be database to only checkout. You get my point? So with that, the application scales without any hassle. You understand my point? That's why we are saying that Docker is a means to microservices. Is a first layer to microservices. You understand? You can put your application in small containers, part of your application. You know, for monolithic, the application is bundled into one single system. Everything is together. But for microservices, you can separate, you can demarcate the application. You can just split out that particular application, that monolithic application to what? Microservices. Typical example is what I've built right now. So I can actually allocate this part of my code, of my application for only payment. This part for authentication only. This part for maybe sending bulk SMS only. And that's what it does. And the beauty is that I can ship this particular image to another person, another server, and make a deployment without any hassle. Once I have Docker runtime running on a particular server, you get it. Because everything is together, everything is within the image, all the environment, all the packages, all the dependencies, all the metadata, everything is in a particular image, that particular image. So I just move them around without any hassle. That's the beauty of it. Okay. Yeah. Okay. So that's it for building and running the application. But let's see. This is not the end though. I think we just started. Now, if I want to make a change, is it going to reflect? I don't think so. Because there's no connection from your local machine to the container. That whenever there's a change, it should reflect. You get it? So how do you do that? How do you make sure you have a full backup or you have a stateful application like a database being stored after the container has died, or when the container is terminated, how are you going to make sure the changes are being stored, are being kept, are being written to a file that you can access? Okay, so let's walk into that one. Persistency. How do you persist data? Okay, so right now we have 2 applications running. We have 3. Okay, so let's try and make a change and see what it's going to reflect. It won't. Okay, so let's say for instance, if I go here, I go to the GS file. Let me see this place. No, it's too much. Let's see. Yes. Let me make a small change and let's see what is going to reflect. So you see the title. Let's use one as a title. Let me see. GS app.gs. Okay. I think. No item yet. Add one above. Let's make a change over here and see what it's going to reflect. It's not going to reflect. We need a change. We need a change. We need a change in Amagana. Okay, so let's see. Typical application, typical node application. This one you have there's another source code watcher for the node or something, right? It keep changes, it keep reflecting, keep updating the system for you. But here we don't have it. So how do you go about that? So this one, if I refresh the page, that's what happens. It's persisting because we have SQLite. That's where it's storing all the kind of stuff. The moment I terminate all these applications, you wouldn't see any because it's not being stored. You get it? So let's see. It's not going to reflect, right? Let me delete these guys. You see, I've made a change, but you don't see reflecting here. Why? Because there's no connection. There's no instruction that is telling the container that whenever there's a change, put that particular changes to this side. No, we're going to do that. Okay. I think before that, let's do the publishing. It's very important. How to publish. Now we have an image. Let's publish the image to our Docker Hub or to our registry. Okay, so let's do that one. Then we'll come to how to do the persistence. All right, so go back. So we have containers running. How do we stop them? It's very simple. So Docker, you see that each container is having what? A unique ID. You can see it from here, right? Yeah, so this is a unique ID that identifies each container. We have 1, 2, 3. Okay, so I'll just pick, then Docker, stop, paste it here. We are good to go. We have to stop. We stop the container. So if we try and grep, you see that now we left with only 2. But what about if we want to stop? We want to stop them, remove them. That one too is very simple. So remove first. It's gone. So we don't have this container in our system. So we do the same for all. I think we left with this guy. So this container, paste. This container 2 is running. Paste. We are good to go. So we don't have them. So we see that when we go here, there's another. Let me see this guy. Okay, so possibly is the image running. Okay, so we are good. So when you go to the web, you can't access them again. They're not there. See, you're all dead. See, you're all dead. You're all dead. All right. So our next is to publish our container, our image to the registry, which is the Docker hub. So let's go there. So Docker hub. Let's go there. So this place housing a lot of Docker content. We'll get there. I think we can also explore. So this is my login. This is my account. So you can see that I have a couple of them. Let's get another one. So this one will be called Nalo. Demo. Yeah, I think we are good. So they make sure it's what is public so that you can have that ease. So let's go. We're good. So let's go to the repositories. I have another demo created. The visibility is what? Public. Private means it's private. Nobody can access it. Me alone. I don't want to do that. So it's public, right? So let's go and push our image. Let's go and publish our image and see how it's going to turn out. So before you can do that, the first thing you're supposed to do is you log in using the Docker Hub CLI. So let's do that. So Docker login authentication. Yeah, so login succeeded. Okay. Now let's tag mostly the tag helps to identify a particular image. Maybe you build a couple of images, right, with different changes. Maybe version 1, version 2, version 3. So the tag will help you to do kind of math, right? So let's do that. So Docker tag, right? Which image are we tagging? So Nalo demo dash Nalo Docker demo, right? Then the tag name. So I'm saying that Alexander, that's the name of my account first. Then the name of the repo, right? Which is Nalo demo, right? Let me confirm. Yeah, Nalo demo, Nalo demo. So let's see how it goes. It's done. I've tagged this particular image. And let me push. Let me see. So use the Docker. We are going to push this particular image to the repo or to the Docker Hub repo called Nalo demo. So let's do it. So push to Docker push. Let's see. Yeah, you see that it's pushing, right? So let's wait for a while. Let me go and check. So essentially, we should have a Nalo solution separate account where we can possibly or start pushing our images. I think this one will go to, okay, you don't worry, maybe that will be another discussion. All right, so we are done. The size is what? 17, I don't know whether it's kilobyte or mega, I'm not aware of that. But let's go. Let's go and check whether we have it here. So let's refresh. The demo. Wow, we have it here. So here we go. So like I said, because I didn't add the version, see, just by default, it will add the latest. We could possibly use numbers, maybe 1 point something. You get my point. A few seconds ago, okay? So this is what we have. This is what I have in this particular repo. Okay. So how do we pull the copy? Let me see. Who is here with me? Divine. Hello, Divine.
Hi, Alex.
Can we pull this one? And let's see how it goes. Pull. I've shared in the chat.
All right.
Yeah. So let's say Divine is a DevOps, not actually, it's a deployment officer who is part of the operation team or the support team, typically a NOC team, right? I'll just send him the what, the image name, then you will just deploy and you know that. If you want to automate stuff, this thing will be part of our CI/CD pipeline. Okay. So once we finish building the image and we push it toward the registry or to the Docker Hub, automatically it will pull, then deploy into the other service. That's all. Very soon, I think we'll be able to do that. Then everything will be automated. So we'll be at home, then just one command, things will be happening, right? So we'll get there. We'll get there. Those of us who want to join the DevOps and the SRE team, very soon we'll start doing magic. All right, so I think that's all for how to publish your image, not your container. You publish your image. So others or other parts of the development flow can actually use the image and create an instance of it. That's what the container, the separate service. Okay, so you can see that the image is portable. I can just ship it to anyone at all. I can just send the image name to a particular person. Then you just pull it and you run it anywhere. You get it. So that's it for publishing. I think the next thing I want to talk about is how to make your data, your source code persistent, as well as your database data persistent, so that when you shut down the container, the data will still be there. You understand? You know, when we shut down the container, we never had the data back. Well, let me show them. Let's try to instantiate one of these containers, one of these images. Then let's add this one. Okay.
Hello, Alex.
Yeah, PK.
Yeah, please, you have 5 minutes for
Yeah,
then a few minutes for questions as well.
Okay. So you see, what I was saying about the persistency, we were able to create some few to-dos, but let's see whether we get them. We've created another container out of that particular image. Let's see whether we're going to get them. We won't, because there's no persistence. There's no stateful persistence. Okay, so we didn't get them. Let me see. It's on port 3002. 3002. You see, it's not there. There's no data persistence. So maybe our next, hopefully tomorrow, we'll take it from here. Okay, data persistence, the network, how to connect multiple containers together, that kind of magic. So hopefully tomorrow we'll do that. Okay, but for now, I'm going to end over here for questions and answers. All right. Any question?
Okay, Evans has his hands raised.
Yeah,
Evans, you can
Evans.
Yeah. So my question is about the Docker Hub. Is it advisable to publish your image to the public? I mean, anyone can just pull your image and decide to run it and deploy it and use it. So let's say if you're working for a company, acknowledge.
Mhm.
Is it wise to make, you know, your image public?
Good question. So that's why we have the public and private. The public means it's exposed to entire universe, to entire world, right? So that simply means that it's something that you want to share. Let's go here. Let's go to the explore. There are a number of containers that have been published here for people to consume from the community. You understand? You understand? Let's say Node.js. Okay, Node. So all these are free. You can just, some of them are not free though. You understand? So you see, most of them are free. You can just pull them, then you run an instance of it, then you have a container running. You get it. So let me get back to your question. So it's not advised when you know that that particular image is for a company. Let's say Smartcast, let's say SMS portal, then you create an image and you put it to a public domain. No, that should be private. Okay. Or you can also put it to what? The local registry that you can create with Docker. You understand? So it's like that. It's not advisable. If when you know security is a concern, you don't have to do that. Okay. But if something that you want to share, like what I just did right now, then why not? Okay. Yeah, next person. Have I answered your question?
Yes, please.
Okay.
Thanks.
All right. The next person, please.
Yeah, Lawrence, go ahead.
Okay. Alex, I wanted to ask about the copy and then the run and then the command in the Docker file. I want to know, since they are all running some Linux command, when do we have to use what? If you check, I think lines 5 has the command, and then line 4 has the run. So I want to know the difference. Can we use them interchangeably, or when are we supposed to?
Good. Another good question. You see the run there? The run actually installs utilities, right? Let's say what you normally do with your Linux terminals, the kind of command that you run on your Linux terminals, right? Now, once you have the utilities in place and you want to run a script, you understand my point? So in this place, before you're able to run the index.js successfully, you need to have the package being installed. You understand? That's why we use the word the CMD. But for the run, any command utility or any program in Linux that you think is part of your base image. Okay, this guy. If it's Linux, you know the kind of commands that will be there for you. You understand? You can run them, but you can use the run to run them. You get it? Now I'm using run yarn install production because I know that this particular image that's coming from the public repository or from the Docker Hub, okay, has yarn installed. Do you understand? So I can just call yarn install to this magic for me. But because I want to run a script here, I need to have the packages installed before I can run the script. Then you go for what? The CMD. You understand? So the CMD is more geared to what the user can do, like your personal script or your personal command that you want to run. But the inbuilt commands into what? Into various operating system, you can use the word the run. Have I answered your question? Or you still want some elaboration? Okay.
Oh,
all
okay.
Right. The next question.
Yeah, let's go.
Yeah.
So I noticed that you were running the services outside the Docker file. Is it deliberate or because of the demonstration? I normally come across where we separate the services commands from the dependencies command, how do you call it, script. So I was expecting that probably you create a YAML file to run this, to actually track the services in it, like the expose ports and other stuff. I was thinking you're going to place them. You know, you run a command where you specify the ports where the app should run. So I wanted to know that is it also a convenient way of doing it, or I mean, the best practices, are you supposed to create a YAML file where you can specify the ports to run the app, so that when you, as soon as you run the command, one command, then the system picks the file and then it actually runs everything and actually deploy the app, or you can actually run the specified ports in the browser without actually running so many commands.
Okay. Yes, so what you are saying, you are right, we can do that. This particular lecture or this particular training is meant for the beginner as well as advanced. So I have to start from the scratch. So hopefully tomorrow we'll be doing the Docker Compose. That's where you see the power of combining multiple services or multiple applications together and bind them so that they can actually talk to each other, especially when you have JS backend with a database sitting somewhere. You understand? So I do understand what you're trying to say. Yeah, so we can do that. Yeah, but just that we'll not reach there. Hopefully tomorrow we will take it from there.
All right.
Any question?
Hello.
Yeah, boss.
So I see in the Docker file, in the copy instruction, you copied all the files on the host to the containers file system. So I wanted to ask if there's a way of like excluding certain folders or files from being copied into your Dockers and your containers file system.
Yeah. Yeah, you can do that. So mostly you can use the add, right? So as you can see, the source and the destination. So you can, let's say I don't want to copy this. I want to forget about everything. Then I want to copy the package. Anything called package. Let's start with package.json into the words, into the current directory of the container. You get it? So this one to pick only the package files. You know, we have the package JSON, the package lock. You understand? Those people with no JS experience, you have the package word lock as well. So you can actually exempt some of the file. Yeah. So these are the magic. There's so much into this. This is just the surface. Okay. So you can exempt them. This is not the exhausted list of directives that you can write into your Docker file. There are a lot of them. But this is the fundamental. Once you get these ones right, you are good to go. Okay, so you can do that. You can do that magic. Yeah.
Okay, thank you.
Welcome. Next person, please. Okay, so if there is no question,
I think I have a good thing.
okay.
So we're thinking it was going to be on a live server, since it was, you guys are going to teach us to deploy it. So we are thinking you are going to complete your presentation on the live server.
Yeah. So it's part of the plan, and hopefully tomorrow we should be able to do that. Tomorrow is a deployment on using Docker, as well as using the raw WSGI or the raw environment. So we'll be doing that tomorrow, hopefully. So I'm just hoping that tomorrow we have enough time to do that. You understand? But the key part for today is to understand the basics, the essence of Docker, and how to build a Docker file, how to use the directive in the correct way, how to build, how to instantiate the image, and possibly add word persistency, but we couldn't do the persistence. We're able to publish to the registry or Docker Hub. So tomorrow we'll continue from there. So tomorrow we'll be doing the persistence, how to create volumes, how to create networks, how to combine multiple containers, how to use the Docker Compose, how to deploy it, possibly to add cloud. If time permits us, we'll seek permission, then we deploy to the cloud. Yeah. So it's possible. It's possible. Just that time is limited. Yeah. So tomorrow we'll continue from here.
All right.
Any other question? I'm expecting more questions from the NOC team because eventually the NOC team will take over. I will do. Okay, I will do right now. There you are.
Alex,
you are keen. So
this one is a DevOps job. You know, be no team job, yeah.
oh, someone of my
now not is DevOps. So
when you're DevOps, will be on it.
hey, catchy. Okay, let's hear from you.
Alex, me.
Yeah, Andy, I thought you asked a question.
No, Alex, I don't have any question. I just correct you.
You are just prompting me that the DevOps there.
Yes. Maybe DevOps need you, man. Into more people be a man and me.
Okay, I hear you. Yeah, Solomon.
Yeah, hello Alex.
Yeah, Solomon.
There's this problem I usually have. Like sometimes from within the container, I want to access a service on the host. And you know, from within the container, you can't just use localhost there because its localhost is not your localhost. It's not the host localhost. Sometimes when I specify, so I use the IP, the host IP. Sometimes it works, sometimes it doesn't work. And I don't understand. Sometimes I get connection refused. I don't know.
That's the beauty of
So
beauty of programming.
to be frank, I have also gone through the same issue, and there's a solution to it. So let me say something on this thing for you. I think so. Docker has actually made provision for it, for you to connect from the container back to the host. Okay, without any help. They did provision for this, so I've shared it. You get it. So what you check? Yeah, we have this particular endpoint that you have to use. You want to connect back to the other services or possibly other on your host. So we see that we have the host.docker.internal, right? Then the port will represent the service that you want to access. You understand? So let's say if the database service is running on port 8,000, then you specify it over there. You get it.
Oh, nice.
That's the way out. You get it. I had that issue when I was working with I think Redis, right? I was trying to find ways to connect my Redis outside the internal network of the Docker Compose. You see that thing? So let's say you have a local area network, which is your internal Docker Compose network, right? And you want to access other containers outside that particular service, that particular network. This is the magic. Okay, this is the magic. This is how.
Okay. Thank you. This is a lifesaver.
All right. Any other person? Okay. So I think almost all of us are good to go. Tomorrow, we'll go again with more practical. And I think by the end of the aim is that by the end of this seminar, we should be able to conversant, use Docker confidently in our deployment and our application development as well. So, okay, I don't think we have any question. I don't think there's any question. So,
All right.
I'll call it done.
All right.
Yeah.
All right. Thank you very much, Alex.
You're welcome.
Like you rightly said, tomorrow we'll have the deployment sessions, and then I would want to entreat everyone to come around and come on time, so that we'll be able to get hands-on practicals into, setting up the Docker, deploying, and then any concerns that you have or any issues that you run into. Since it's going to be a physical meeting, you will most likely get all your concerns addressed. So Alex, thanks once again.
You're welcome. I think one more thing, I think those of
Yeah.
us who don't have Docker running our local machine, please let's do so. So that tomorrow, all of
Right.
us will have experience.
Right.
Yeah.
All right. It's free. It's free. So just get it installed on your system, get it running, then you'll be fine. Okay. So we have 2 more sessions. We have AWS, and then we also have some configurations. We'll be zooming straight into section 2. Now, section 2, you are going to have it in 3 folds. So first and foremost, we'll be having SSL manual provisioning. We'll have DNS configuration, and then DNS security. I don't know the order in which our resource personnel will want to take them, but these are the modules that we'll be treating in section 2. And then right after, we'll probably have a break, depending on how our brains will be treating us. If we feel that we are good to go, we'll continue right after that. But then if not, we'll probably have a break in between. And then we'll have AWS training. So I believe our resource is ready. Eric, Awudi, and Andy Otu. If you are ready, please, the floor is yours.
Andy, good morning.
Okay, why you mention my name? I'm no longer part of the listing.
Well,
Andy, why are you trying to do that?
If you get to the demonstration you want me to demonstrate, I'm available to demonstrate. Right? It's
Okay.
only Eric who's going to do this.
Fantastic. Eric, before you take over, I want to see some thumbs up from those who are around. I want to confirm that everybody is actually here and our eyes are wide open. Okay, so Joseph, I can see your hand. Guys, I want to see that. Yes, Sydney, I can also see you. Fred, fantastic. Eben, that's right. Lawrence, I see you. Nee, I see you. Sayram, I see you. Jojo, of course. It's Jojo. Labs, I see you. Divine, Evans. I've not seen, goodness, have I seen you? I've not heard from Goodness. Goodness, are you around? Okay, so the majority of us are here. Eriko,
Yeah,
the floor is
okay.
yours.
Yeah, PK, sorry for the interruption. On the sheet that you shared,
Yes.
I was expecting that Eben will be the next person, or you jumped.
Yeah, so I've communicated to Eben. Unfortunately, Eric has a meeting, another meeting, so I had to modify it a little.
Okay.
Yeah. Eric, please, you can proceed.
Oh, okay. Andy. Okay, so
Eric,
this,
do you want me
yeah.
to share my screen or something?
All right, we'll get to that part. Yeah,
Okay.
so good morning, everyone. Hope all of us are doing well. Just want to talk more about the things that we've been given to to present, and then afterwards Andy will step in and then give us some show. So it's on DNS basically, and then SSL provisioning. I put together some definitions here. Let me share my screen. Okay, please let me know if you can see my screen.
Yes, you can see your screen.
Good. All right, so DNS stands for it has some form of architecture that has been set in motion to translate human readable names into IP addresses. So if you visit the web browser and then you type in anything at all on the internet, which is a URL, www.example.com, what happens is that this example.com that you have doesn't go directly to where your application is sitting. No, the internet doesn't actually understand the domains that we've been given, example.com. What happens is it picks that domain and then go to a lookup server, let me call it that way. And then that lookup server translates or maps the name that we have to the name that is entered, example.com, to an IP address. It's only IP addresses that your system or the internet actually understands. So where you have your application deployed will have an IP associated with it, basically. And to reach your application, you need to use that IP address. But we are humans, we can't memorize numbers all the time. So with the names that we have, the DNS system will actually translate these names into actual IP addresses, and we'll be able to access the resources that we have. Now, the main components of this DNS server that we are talking about are three, if we are to break it down. We have a sub resolver, and we have a recursive resolver, or a caching DNS server. And then we have a number of authoritative name servers. Now, this sub resolver, we are saying that it's something that acts as an intermediary between you, the client, where the client here can be the browser, the web browser, like Chrome, and then the recursive resolver. So upon a successful request that you send on the internet, this sub resolver goes to the recursive resolver and then make inquiries to find out if this URL that you've entered has an associated IP address cached on the server. If that is the case, then this cached IP address is further resolved, and then you can actually access your resource on the server. If that's not the case, then the recursive resolver then pass on the requests. We have a .com to be resolved, and then we have the main domain to also be resolved. And that is handled by the third one we have here. That's a number of authoritative server that we have. In brief, we can demo it like this picture we have here, where a sub resolver goes to your recursive resolver, and then we have quite a number of authoritative servers to validate or to translate these things for us. The benefit of this is that at the end of the day, humans are able to enter these URLs, and if they are cached, I wonder if I can actually, you can see my screen, right? Okay. If they are cached somewhere here, then things will be a bit faster for you to, and this is actually one reason why when someone actually fires our API the first time, it takes quite longer than when he fires it subsequently. So if things are not cached, then it goes directly to where we've actually hosted, or where we have, where our materials are at, and then get these things and then bring them to you. That's the server that this one is sitting on. Our resources are sitting on, then brings this thing and then forward it to you. But subsequent ones, we will have it cached somewhere, and so things will be a bit faster. Yeah. Moving on, the security bits of things, DNS also has some security protocols that are in place. At this point, let me just read what we have on the screen. So we have the DNS security extensions that we are saying add cryptographic signatures to DNS records for authentication purposes. And then we also have DNS filtering if you want to also block certain traffic from certain IP addresses. That can be done at the DNS level. And we also have DNS firewall also in place to prevent some attacks that can actually occur on the DNS service. The good thing about all these things is that Nalo as a company, we don't really worry much about these things. Our DNS providers have these things in place that protect us from all these things. What we usually worry about is after deploying our application, if we have our own server, we rather implement some kind of firewall security on the server. If the application is on AWS, AWS also has some services over there that will help us to block certain traffic, open certain ports, and then the like. And so, yes, we are catered for here. Now, there are different types when it comes to DNS that can actually be set. We have one that you can point directly to an IP address, a Class A record. Usually when you want to point the URL to a domain, we usually create a Class A record.
Eric,
and then, yes.
go back on the security side.
I missed something.
Yeah. Yeah, I think to add up to what Eric is saying, we are not handling this, but fortunately for us, we have our providers, our host providers doing this for us. So the reason why you need to protect your DNS records is because your DNS can be tampered with. Imagine someone typing your website www.nalosolutions.com, then a hacker has poisoned your DNS cache, right? And then it's redirecting whatever the person is typing to a different application or website. Yeah, I understand. So it's just going to if you don't have something like this in place, security wise, your domain can just be brought down as easily using cache poisoning or what was the other one called? Denial of service. So with DNS security, once you secure your DNS records, you prevent this kind of attacks from hackers also. So that's why if you have a DNS, it's very, very important to protect it against hackers.
Thank you very much. Yeah, that's very true. Yeah, so like I was saying, with the configurations, if it's a resource on a particular server and you've been given an IP and you have your domain sitting somewhere, all you need to do is to create a Class A record and then point it to the where did I get to? I forgot my next slide. Yeah, create a Class A record and then point it to, yes, point your URL, that is your domain, to that's Class A record that you've created, and you'll be sorted. If it has to do with emails, it's MX record that you'll be creating. And if you also want to validate a domain itself, not just the MS record, but you also have a TXT during our onboarding for some clients on the email platform where we needed to validate the entire domain. We generated an MX record as well as a TXT record where they added it at their end. Now, with DNS, another one that we can actually create is NS record. I don't know why that one wasn't added. So that one you are kind of. So currently we have one platform that we use for our DNS configurations and everything. That is called the cloud DNS. But say, for example, we buy or we purchase a domain on a different hosting platform. Let's say GoDaddy or Hostinger, and we want to manage that domain on Cloud DNS. What we do is that we go to Cloud DNS and then add or change their DNS record to what Cloud DNS has given us. So that now on Cloud DNS platform, you have the full authority to do whatever you want to do on the URL. I don't know if that makes sense. If I communicated well. Yeah, I think so. Okay.
No, Eric, it didn't make sense.
It
Can you
didn't.
come again?
All right. So say say you bought a URL, okay, a domain, sorry, on GoDaddy, let's say example.com, and you want to manage that domain. We can actually buy domain from anywhere at all that we want, whether on Amazon, Route 53, or Hostinger, or any other platform. When you do that, at the end of the day, your management will be scattered. If you want to, for example, create a subdomain on example.com, which you bought on GoDaddy, you have to go to GoDaddy and then create that subdomain and do that, whatever you want to do. The management will be done on on GoDaddy. If you bought a different domain on a different platform, you have to also manage it over there. Okay. So we want to manage everything on just one platform, that is Cloud DNS. So in that case, what we do is that we just create or we just pick Cloud DNS NS records and then go to GoDaddy or Hostinger or whichever platform that we've bought our various domains which are scattered all around, and then change their NS record to the one that we have on Cloud DNS. Once that is done, we've given Cloud DNS, just like how we've the people that we onboarded, Fidelity and the like, gave us the authority to whitelist anything.myfidelity.net. The same way we've given Cloud DNS the authority to do whatever he wants to do with our newly purchased domain, which is sitting on a different platform. Lawrence, you get it?
Yeah.
Yeah. So that's basically it on DNS and then itself. We come to SSL best practices, and then we can Andy can take us through some demo on these things. Yeah, so SSL for Nalo solutions, at least the service that I know of, we don't really worry much about it. I understand that as a company, we have our own SSL generated or bought from GoDaddy. And then these platforms who have the authority to sell SSS certificates to us basically follow best practices. And these are some of these best practices. They make sure that their SSL algorithm, encryption algorithm is solid. Key length and everything is on point. Once it expires, they have their own way of automatically renewing it unless you've not paid for it. We also have implementation of HTTP strict transport security, which enforces connections and prevents downgrade attack. Sorry, I read that one verbatim. And then the last point also over there. Yes, so every time, at every point in time, once they realize that this particular certificate that they've generated for you has been compromised, it's their duty to regenerate a new one and then to fix whatever patch that they have there. So GoDaddy, the SSL that we bought for anything.nalosolutions.com or the domain nalosolutions.com, makes sure that best practices are followed because we've actually paid for that service. Now, the cheapest SSL tool that we use, which is also free, is Setbox. On some of the services is Setbox. I'm sure most of us know about setbots. So setbots really is free, and their aim is to provide free SSL for everyone sitting on the internet so that our communications are well secured. The only downside with SSL is that sometimes if you want certain things from the user who is interacting with your application, you will not actually get, because SSL provides a secured version of the HTTP protocol. So you have HTTPS. So for example, if you want to know the user's location, where the user is sitting, these things are passed by the network operators or the ISP, like MTN, Airtel, or whoever is providing you with internet. They are passed on to us in the request. But if your connection is not on SSL, you will not actually get it. You will not get these things. A typical example that Nalo we really want is numbers, people's numbers. So the one coming in, what is this NSISDN? That is passed to us through the URL that the person enters. That's the header body of the request that comes in. So we have it here, but if you're on SSL, SSL is a secure version of the HTTP. You will not get all these things. That's just a downside of using SSL. But aside that, it has its own enormous benefits, which we are all aware of. If it's payment transactions, no hacker can sit in between your request and then grab the details. Yes, he can grab the details of the request body and everything, but it won't make sense to him because the algorithms that were used to generate the SSL certificate really encrypts your data, which is going through from one station to the other, from hub to hub. And so he won't make meaning from the data that he's been able to intercept. Yeah. Okay, yeah. So yes, with this, what I will just end my presentation is the fact that on AWS, which I'm sure maybe in tomorrow's demo session, maybe Eben or someone will present on it. We have a tool that helps us to generate our SSL certificate, and with the help of that tool, we don't really need to do much manual work. And if you also want to buy, that is the one we have for nalosolutions.com. We just go to GoDaddy and then renew. We select the type of certificate that we want, and then we renew, and then they do the work for us. Yeah, basically. I think, Andy, if I miss something, we can chip it in before you. Okay, John is here. This is Aquaba.
Eric is fine.
Okay, cool. All right. Do we have any question on this before we move to the demo side?
Yeah, Eric.
Yes, please.
One question.
All right, sure.
Can you go back to the DNS? No. Yeah, the first question.
Okay.
The stop resolver, is it in the cache of the local machine or operating system, or is it a separate server? I didn't get that one.
And they really want to come in?
Alex, is the resolver of your local machine. So we have resolvers on your local machine. We have the one from the network operators, and then we have one from the authoritative servers.
Okay. Okay. So you are saying that ideally, whatever comes out as a result of the DNS lookup is being stored in the local machine. So in the subsequent request, it goes straight up to the local cache. Then instead of going through the old route, then you just go straight up to a particular authoritative server, then that'll be it.
Yeah.
Okay. All right. I think that's okay for my end.
That's cool. Any additional question? Okay. And Andy, can you please demo for us maybe creating a record and then pointing it to maybe google.com. Did I say google.com? Sorry, Google's IP is what I think it. Maybe shortcode server. Any we are able to access it. Yeah.
Okay, sure. Can you guys see my screen?
Yeah, you
Yeah,
can
we
just
can.
So this is basically our main DNS provider. This is where we have all our domains seated. So any form of subdomains or subdomain creation, CNAME creation, A-name record creation, and the rest is done on this server. All right. So as you can see, we have all our domains here. We have Beep Online, we have My Mail Center, we have NaloPay for the payment engine. NaloSol is a backup for nalosolutions.com. And we have the NaloVAS, which is for the VAS department. What's this? I'm coming.
Andy, what about the backup.nalo solutions?
Oh, the other one was for when we were migrating the service to this platform.
Oh, okay.
Yeah, we used to be on I think we were on side 5, and then we moved to AWS, and then we moved to this side. So we did that just in case it goes south.
Oh, okay.
Yeah. So we have other domains like Quick SMS, Smartcast Online, Swipe, and then wireme.com, which we are no longer going to be using. So let's take a domain like Smartcast Online. So when you click on that domain, you can see the various how do you call these things? Let's say they are classes. Okay. So to create a similar class area record. So a class area record helps you point a domain or a subdomain to an IP, right? So if you want to create a class area record, you just add a new record for Smartcast. What do we create? I don't know if we have this thing. So let's say testing.smartcastonline.com. So usually what happens is that the developers, they share the kind of subdomains that they want. That's the backend or the front end team. So they share the kind of subdomain that they like to create for their domains. And then once they provide that, they also add the IP that they want to point that subdomain to. I don't have anything in mind, so let's just use a copy of what we've already created. All right, let's use this, the staging. So on the portal, if you have an existing class A record, which is pointing to an IP that maybe you want to create another subdomain pointing to that class A record, there's a certain button over here that you just click on. It will just load it with the similar record. So all you need to do is just to change the host, and you are good to go. So the type over here shows which record it is. So it means you can change to any other record. The TTL over here means the time it takes to update the record. So let's say if maybe we have staging.smartcast.com, right? Alex, stage is testbed, right?
Yeah.
So I can touch it, right? Okay. So what the TTL means is that I think it's time to label also, right? It shows how often you should check, you should update your DNS cache, right? So if you set it to 1 hour, it means if I do any changes, right, it should be updated within an hour, right? So that's what the TTL is for. You can go as low as, I think, a minute or 5 minutes. Yeah, you can go as low as 5 minutes. But what this does is that it means every 5 minutes, multiple DNS resolvers would be hitting your authorization server, right? Trying to query if there is any changes. So I think the best time is usually an hour. If you set it too high if you do a change, it means it will take quite some time before it's eventually resolved for everyone. So we at Nalo, we usually do ours at an hour.
Hello, Andy.
What the TTL means? Yeah.
Yeah, so I want a little bit of clarity on what the change actually is. As in changing configuration, right? Or what exactly?
Which one are you referring to? Are you referring to the host or the TTL?
The TTL, you said at the moment 1 hour means if you do a change, it checks for changes in an hour. So what changes? Because I know changes in the code, that one based on your deployment on AWS, they'll reflect. I want to know the change you're referring to here.
So the change I'm referring to is the time that DNS resolvers around the world needs to check on this host to see if it has been changed or it's still the same. You remember Eric talked about some stub resolvers and other authoritative resolvers. So there is a time within that resolvers, right? So if you set it to 5 minutes, it means every 5 minutes that resolver is supposed to call your authoritative server, right, and check if there has been any changes on your domain, so that it can update itself.
Yeah, thanks. I think it's clear now.
All right, sure. The host over here is for the subdomain that you would like to create. If you are creating it just for a new domain, you can leave it blank, and then it will pick. And then the points to over here is the IP that you want to point the class A record to. Yeah. And that'll be it. So let's go back to creating a sample. So testing.smartcast.com. We'll point it to the stage IP. 3.133.93. Sorry, 3.122.121.221. And once you do that, it just updates at your end. Then within an hour, it would have changed for all the DNS resolvers. So let's say if we go to so if you want to check if these changes has taken effect, there's a domain name resolver that you can use to check. I think they are called what's my DNS.net. Right. So let's go and paste it over there. Let's see. So as you can see, testing it hasn't taken effect everywhere. As you can see, it has taken effect in some countries. Within an hour, all these places should be changed to green. Then we'll be good to go. Anyway, let's delete this. And if you want to add a CNAME to, so CNAME is just pointing a domain or a subdomain to another subdomain. So this is usually helpful. To me, this is usually helpful if, let's say, Nalo Solutions is changing their domain. Maybe we don't want to be called, we don't want to be using nalosolution.com again, or maybe just like the way we were using wiremeonline.com for our payment, and then we realized that there is already an existing user having that wiremeonline.com. What we can do is that we can create a CNAME record and point it to the new domain. So over here, the new domain will be nalopay.com. So you can just create a CNAME record pointing www.wiremeonline.com to what's the name? www.nalopay.com, and then it will be fine. That way, all the users who were accessing your old website or your URL, they won't be left hanging, or so they won't see that your site has crashed or anything, because you've provided some form of a CNAME or a redirect to another domain. And I think let me talk about the text. So this is the TXT class or record is usually for verifying whether you are the owner of the domain, right? It's one of the ways that you can verify ownership, or you can validate ownership of a domain, right? So if maybe you are doing something on a domain and then you are asked to validate whether you are the owner of the domain, those who want to validate it will usually send you an email for you to add a record, a TXT record in your domain. Once you do that, they'll be able to verify that, yes, indeed, you are the owner of the domain. I think the rest of the things, it's not really important. But okay, I know about the DDS too. Yes, in the CAA. Okay, I think that will be all. I'm going to any more details. This should be
Only
enough.
one question here.
Yeah, sure.
With the records,
Mm.
how do you create how do you create the domain-based message authentication, reporting, and conformance? Because I don't see it over there. How do you create it?
How do you create the what?
The DMARC, the domain-based message authentication, reporting, and conformance. You know, mostly what yesterday the guy said in the mail.
That hacker guide. Hold on, I'm coming.
Yeah, how will you create that one?
Alex, hold on for me. I mean,
Okay.
Alex, whilst you're holding on, I want you to break your question down further so those who don't understand it itself.
Okay, so for that particular record, normally when you create, you add it, you publish it in your domain records, right? What happens is that it ensures that the emails or the message that is coming from the authoritative server, okay, is authenticated or is having an integrity as well as the authenticity, just to ensure that no one can spoof or no one can masquerade the actual generator of the actual source of the email. You get my point? So when you have those records in your DNS, when you get to the mail, when you get to the mail server or the mail provider or the recipient mail server, is able to verify the actual source of the email. If 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 it's coming from, if it's not coming from the actual authenticated server, the digital signature or the hash of the digital signature, there's going to be a change. Therefore, it will drop that particular email. And if it's coming from the actual server, it's able to read that and avoid any sort of phishing attack. Yeah, so I'm just asking how to do that because I didn't know this kind of stuff. I hope we are clear.
Yeah, thank you.
It's a security something. Yeah. So I wanted to know how. I don't know how to do it. So I wanted to know how to do that.
Alex, I'm back.
Yeah.
I think that configuration is done on AWS. Is Francis on this call?
I don't think so.
That kind of
It's
configuration be done on
Okay,
AWS.
we can move on. I think it's not part of this. Yeah.
Yeah.
But
Eric,
I thought maybe
Eric,
Claudio can do it.
Eric,
Yeah.
when I
Yeah.
was doing the DNS security, right?
Mhm.
So I tried inserting it over here, and then I was told to go and add it to how did you call it, to wherever I got the domain from. So I informed Francis and he's saying our domain is seated on Route 53 AWS. So I had
Yeah.
to go there to go and insert these records. So if you are going to do any DMAC, I don't think it will be done here.
Mhm.
I don't know, for Francis, you can correct me if I'm wrong.
I think it's engaged at the moment.
Okay.
I think then it's going to be where we also do the DKIM.
Yeah.
The domain key identity mail.
Yeah,
those configurations that we do for Fidelity and other banks.
Okay. But that one there, that is going to be on AWS.
Okay. All right. Thanks. Then I think once it's done over there, you come and publish over here.
Yeah.
This is a typical DNS stuff.
Okay.
All right. I think we are good to go.
Please, any other question before I hand over to Eric and I'm done?
Okay, and I don't think there are any more questions. I can't see any hands. So I think you're good to go.
All right, sure. All right, guys. Eric, I'm done.
All right. Thank you for that. Yeah, so that's basically on I think we've been able to exhaust our 1 hour. If there are any questions, since it means none were directed to Andy, I don't know if Okay, so silence means we all understand. All right, but if you want any further info on DNS, SSL things, you can always reach out to us. We are there to support 24/7. You can either write an email to noc@nalosolutions.com or you put it on our page and then tag NOC. You will be there to assist.
Annie, see, there is one where you can have multiple subdomains and the one that you can't have. Can you elaborate on that one for us? Sometimes you can have multiple subdomains and some of the configuration don't allow you just have one subdomain.
Alex, I'm not familiar with that one.
Oh, let's say
You having like
let's
multiple
say
domains. Why are you using a shared domain or something?
so that's what I want to understand, like how to do that. Like let's say for instance, we have the main domain, knowledgesolution.com, right? Then we have test.knowledgesolution. We have deployment. That kind of stuff. I think there's a configuration around it too. I don't know.
For limiting you from creating subdomain. And I think it's to the kind of accounts that you are having. Because if you manage your own subdomains there, I don't know why you won't be able to create any multiple unless it's a shared one.
Yeah, that's true. So for shared ones, sometimes they actually depends on the package. They limit and then they tell you that on this you can have maybe 3 maximum subdomains on it. So those ones, they are restrictions that they've put in place because you're on that package.
All right. Thank you.
All right, thank you very much, Andy. Thank you, Eric. It's been an eventful first 2 sections so far. Time check, it's 11:03. So I want us to have a very short break. When we resume, we will zoom straight into the 3rd section. Is it a good plan, or do we think we can handle section 3 right now? Everybody's quiet. I'm suspicious.
Okay,
I think we'll take the break.
Okay.
But
And
can
just
you
what
confirm the number of sessions we'll be having for today?
So that will be our last session, actually.
Oh, okay.
Yeah. Tomorrow we'll have a more condensed session tomorrow because it's will be a physical meeting, and then we'll have a lot of hands-on practicals. So after the break, we'll have our last session and we'll be done.
Okay.
Okay. All right. So I believe 11:45 would work. So we'll resume at 11:45. And please let's do well to join on time. Okay. It becomes stressful trying to get everybody joining on time. So please let's do our best to join exactly at 11:45. All right. Thank you all so much. We'll meet again at 11:45.
All right. Bye-bye.